All right, so we're looking at bar models today, and I hope to teach you the difference between the two basic bar models that we teach second graders to use in order to solve addition and subtraction problems. So the two we use are the part-part-whole bar model and the comparison bar model. And they differ in you use the part-part-whole bar model if you're talking about one set of something that's divided into two or more parts, and you use a comparison bar model if you have two quantities and the difference between those two quantities. And you're either solving for the difference or either one of the quantities. So I'll start off with the part-part-whole bar model, but before I go into either one of them, I want to be clear that this is just a tool that students should use, and if they use it correctly and they really understand it, then it should give them a really clear idea on whether they add or subtract to solve for the answer. And I hope that they look at it like that rather than just another task they have to do in order to get full credit for a problem. So let's start off with our part-part-whole bar model, which is the first one that we teach them. Basically, it's two bars or more that are connected together, and you would have bar A for part A, bar B for part B, and then you would have C, which is equal to the whole. And bar modeling is based on the fact that even second graders can pick out the largest number on the bar. So they should be able to see that since A goes from here to here, B goes from here to here, and C goes the full length from here all the way to here, that C is clearly the biggest number. It is also based on the fact that second graders understand that if you're trying to solve for the biggest number, then you would add A plus B in order to get the whole of C. Likewise, if you have the whole, if you have C and you're trying to solve for one of the parts, A or B, you would take the whole and you could subtract out one of the parts and you would be left with the other part. So let's take a look at what that looks like with numbers. In this case, we have the whole, which is 437, and we have one of the parts, which is equal to 207, and we're trying to solve for the other part. And if you look at this bar model, and if you've plugged the numbers in correctly, you can see that 437 is clearly the biggest part. So if you were trying to solve for one of the smaller parts or one of the smaller numbers, then you would subtract. So you would take 437, the whole, and subtract out 207. This one down here, you have the amount of each part, but you're solving for the total or the whole. And again, if you look at this, this is clearly the biggest part, and if you're solving for the biggest piece, then you're going to have to add the other pieces. So in this case, you would add 78 plus 63 in order to get your answer. So again, part-part-whole bar models is when you're using a set of something that's broken up into two or more parts, but the comparison bar model is used when you have two quantities and they're being compared. So you would have quantity A, which is represented by bar A, quantity B, which is represented by bar B, and in this case it's larger than quantity A. And then you would have the difference, which I labeled with a D. And this part is just dotted in, or I dotted in, and I call it the more than less than part. So you would use this if you were trying to solve for the difference between two quantities. And again, it's based on the fact that second graders can look at this bar model and they can see that B is the biggest number, and it's made up of A plus D together. So if you're looking for the biggest quantity, you add this bar plus the difference. And if you're solving for either the difference or the smaller quantity and you have the bigger quantity, then you're going to take the big quantity and subtract out which one you have, and you'll be left with the other piece. So again, let's take a look at what that looks like with real numbers. In this case, we have the number of both quantities. We know one quantity is 312 and one is 197, and we're solving for the difference, the more than less than part. So you can clearly see that 312 is the biggest number, so in order to find one of the smaller numbers, we're going to subtract. So we would do 312 minus 197. In this case, we also subtract, but we know the larger quantity and the difference, and we're trying to solve for the smaller quantity. And again, 30 is clearly the biggest piece, so we would subtract 30 minus 4. And in the last example, we have the smaller quantity and the difference, and we're solving for the larger quantity. And again, we can see that this is the biggest piece, and so in order to get the biggest piece, you'd have to add. So you would add 476 plus 392. So those are the differences between the two different bar models that we use for addition and subtraction. And I'll apply those to specific problems in my other videos. Thanks.